thank you for attending this talk. My name is Moemen Mhedhbi, and I have been working at HAProxy Technologies for a couple of years now. I have started as a system engineer where I was deploying, debugging, and integrating HAProxy in different environments until I came to Kubernetes, where I have noticed the great potential HAProxy can bring. Since then, I have joined the software engineering team to develop and maintain our Ingress controller. And I'm here today to talk about how to customize the HAProxy instance in Kubernetes Ingress controller. So, as you may already know, Ingress controller reacts to Kubernetes events and generate HAProxy configuration based on user input. In order to customize the HAProxy instance, multiple types of input are available. You can have annotations, raw HAProxy configuration, or custom resources. In this presentation, we will start with an overview of the controller, then we will go through the details of each input and finish with a comparison between the different types. So, Kubernetes controller implements what we call a control loop. So this is about watching the state of Kubernetes resources and acting accordingly. Then updating the status of these resources if need be, and repeat this cycle. This diagram depicts the control loop, so we can see the controller getting notified about changes of Kubernetes resources, describing the desired state, and each resync period, the controller will reconcile the external rule to make it look as required. For example, when you create a deployment declaring a number of pods, Kubernetes controller will notice that and create the required pods. And if any of them terminate or is killed, pods will be automatically recreated in order to match the number of desired running pods. It's the same with the HAProxy controller. It's going to watch the Ingress resource among other resources and make sure that the HAProxy configuration is synced with the rules declared in the Ingress resource. In this example, we have an Ingress rule requiring that HTTP requests with host test.kubernetes.local and path echo1 should be routed to the HTTP echo1 service. This translates in HAProxy to creating a backend corresponding to the said service and use backend rules with appropriate ACLs. So far, so good, but what if the user wants to configure more options like changing the default load balancing algorithm? The problem is that the main purpose of the Ingress spec is to expose HTTP and HTTPS routes from outside the cluster to services within the cluster. And if we want to further customize these routes, we will need a dedicated input type or location. And one of these possible input types are annotations. So annotations are key value maps of strings used to attach metadata to Kubernetes objects. In the case of the Ingress controller, we can annotate service, ingress, and config map resources. And the controller will parse these annotations and apply the corresponding configuration. If we get back to our Ingress example, we can see that adding the load balance annotation here will make the Ingress controller configure the balance algorithm in HAProxy. And so here we are changing a simple option like load balancing. It can be any other option, or it can be a more advanced behavior, like if we want, for example, to configure rate limiting. As we can see here in this example, we want to configure 15 requests per minute. So we use the rate limit requests and the rate limit period annotations. After processing these annotations, the controller will create a stick table and corresponding HTTP rules in order to track and deny requests if need be. And as you can see, all of this is conditioned by the host and path because we don't want to have to apply this to all traffic, but only to requests described in this Ingress resource. And as we have seen in this slide, annotation can be set at multiple levels: service, ingress, and config map. Some of them can only be on a specific scope, and others can be available on multiple scopes. For example, the load balance annotation, if we set it at the config map level, it will configure all backends in HAProxy. And if we set it at the ingress level, it will configure all backends referenced in that in the ingress resource. And if we configure load balancing, if we annotate a service to configure load balancing, it will impact only the backend that corresponds to that service. Just keep in mind here that the annotation in the more specific scope will always have precedence. For example, we can have global default value for load balancing algorithm in the config map, and we can overload this in the specific service with a specific load balancing algorithm. Some annotations can only be set at a specific scope. For example, it does not make sense to configure global options on a service or on ingress, so global options are only available as annotation on config maps. For example, in this slide, we can see we have a config map to configure maxcon. Maxcon is the parameter to set the maximum number of concurrent connections in HAProxy. So it's a global option, and we set it in a config map. In the end, we can identify the following key points. So annotations are parsed and processed by Ingress controller. They have no structural input, which means input can only be string, no integers, booleans, arrays, or dictionaries. And most importantly, we have this leads to an exploding number of annotations. Because if we get back, for example, to the rate limiting configuration here we are tracking requests by source IP. But suppose that we want to track by host header or cookie, or maybe a combination of multiple options. So in this case, it will lead to an exploding number of annotations. And if we add to that these annotations are not structured, this is going to make it hard for the user to find his way when customizing his routes. To overcome this, we have thought about row configuration. Actually, some users, especially those who are already familiar with HAProxy, reported that they prefer to use row configuration rather than having to use an intermediate input layer. And row configuration can be are available in two parts. We can have config snippets and we can have auxiliary configuration. Config snippets are about inserting HAProxy directive in specific sections. So we can have them in the global section, we can have them the front-end section or the back-end section. And auxiliary configuration, we use it to insert whole sections. So this can be a backend section that we want to have it in auxiliary config file. It will be the static backend, or we can have peers sections or resolver sections. So the most important thing to keep in mind when using dynamic configuration, when using row configuration, is that these are static config, which means the controller will insert it as it is without adapting it to the context or to any Kubernetes events. For example, if you insert a HTTP request rule as a config snippet, the controller will not be able to assign it to an Ingress rule or to any other Kubernetes event. So the same. If you want to insert backends in the auxiliary config file, it will be a static backend, which means controller won't track any corresponding Kubernetes events like scaling up or scaling down. To sum up, we can say that the main benefit of this type of input is that you can use raw HAProxy configuration with no intermediate format. However, this is completely opaque to controller, which means no input validation is done, and the controller is not processing raw configuration, so it's not aware about what we are how we are configuring HAProxy. So that's why we have thought about a different input type, which is custom resources. And to understand custom resources, we can talk first about built-in resources. So these are resources available by default in a Kubernetes cluster. So we have deployments, services, pods, and if these resources are not enough, or they don't describe the user use cases, we can think about user-defined resources. And there we have two of them. We can have choose custom resource definitions or API aggregation. So custom resources extends the Kubernetes resources served by the Kubernetes API server by creating new types capturing the domain-specific schema, which means that we are still going to use the existing Kubernetes API server, and we are just going to define new resources. On the other hand, API aggregation is about creating a whole different custom API server, which allows for much more flexibility, but also comes at a cost of complexity. So with custom resource definition, we are going to extend the Kubernetes API. We are going to have structured data in a declarative way, like we do with built-in resources. And we are going to have an open API schema for data validations. In addition, we can register custom resources at any time when running a Kubernetes cluster. And talking about registering a custom resource, we will use, this is done via custom resource definition. So here we are defining the name and the group, which is the API group code.haproxy.org. We have a kind and we have a plural name for the custom resource. This resource is a scoped resource, so it can only exist on a namespace. Then we have the open API schema, which lets us have a formal definition of what the custom resource should look like. So we have multiple fields corresponding to global HAProxy options, and they can be strings, integers, or they can be structured. They can be in a structured type. Now, once we have registered a global custom resource, we can use it to set global parameters. So you can see here, for example, for the maxcon, we're not using a string, but we're using an integer. And also we can see that we have structured input, which means we can have For example, if you want to add a runtime API, we can specify the address of the API, the level. Here we are talking about HAProxy runtime API, so we can specify its address and level, and we can add also SSL, some global SSL options. All of this, the nice thing here is that we don't have to provide this in a single string value, but we can have it in a more structured way, which is easier for the user. So under the hood, custom resources in HAProxy Ingress controller, they are relying on other projects of that we are working on HAProxy technologies, which are client native and config parsers. So these projects were designed to be able to parse HAProxy and to update HAProxy configurations. The client native in the client native project, we provide models to client native, and client native will update HAProxy configuration according to these models. And client native itself relies on config parser, which is the project that is responsible of parsing HAProxy configuration and make it available to the client native. So in Kubernetes, in Ingress controller, we are reusing these projects to be able to introduce custom resources. We will see we will see in the next slide how to do this. But before moving to the next slide, I'd like to mention that also we have the data plane API project, which relies on the same libraries to be able to update HAProxy by receiving RESTful HTTP requests from the user. Now, in this slide, we can see how we developed or introduced custom resources in Ingress controller. So here we are introducing the new Golang global type. And you can see in the spec, we are using models from client native. So this avoids, so as we have already talked about annotations, the problem was that we don't want to have to develop every new annotation for every HAProxy configuration or every HAProxy directive. And with custom resources, it's much more simpler because we can reuse really models already available to be able to push HAProxy configurations. Now, the key points of custom resources is that first they are structured type of input, and we can have validation. So we can have validation at an early stage, which means when the user applies a custom resource, if it does not match the Open API schema, the Kubernetes API server will reject it. And another key points of custom resources is that Ingress controller is aware of HAProxy configuration, which means that whenever we push custom resource configuration, the controller will know that what parts of HAProxy are being configured. In the contrary, for example, with row configuration, this is not possible. And this is useful for example, if we want to have a smarter configuration of HAProxy. For example, if we want to set a maxcon on the backend, and we are running multiple HAProxy instances, then the controller will automatically adjust the maxcon, this maxcon option. So in the end, we are going to compare the different input types. So with annotation, we see that we have validation, and it can be user-friendly. By user-friendly, I mean something that is easy to understand for a Kubernetes user who does not necessarily know how to configure HAProxy. But the problem that this is too vague and non-structured, so it's not domain specific. It's not targeted to HAProxy configuration, which is the case for raw config type, because we can put exactly the HAProxy configuration we want, but it's not user friendly, which means you will need to think at the HAProxy level to configure your routes. So you will need to provide HAProxy directives, and also there is no validation. And custom resource is the best choice, because we can check all the features which are validation, the domain specific input, and it can be user friendly. Actually, this depends on how we want to define our custom resource. So it can be to configure HAProxy, or it can be on a higher level to configure some general behavior like rate limiting or any other behavior. So what we think to do next is to support Gateway API, which is based on CRDs too. And we may think about providing more custom resources that are more user-friendly, which means they describe a general behavior rather than describing HAProxy configuration. And that's all for if you have any questions.
And now we have Moemen joining us here live. Moemen, thank you so much for your talk and for joining us for the Q&A.
Hello.
As a reminder to everyone tuning in, you can submit questions for Moemen in the general chat. We've already been collecting the ones that have been submitted, and you can also submit them on Twitter using hashtag HAProxyConf. So Moemen, this is maybe to elaborate a bit on the end of your talk, because we had questions coming in earlier, but maybe to elaborate on this. So you would describe several ways in which you can add settings to the HAProxy Kubernetes Ingress controller, annotations, config snippets, an auxiliary configuration file, and the custom resources. So that's quite a bit of flexibility for users. Do you think that the Kubernetes platform is evolving to favor one approach over the other, or does each have its own place? I know you touched on this at the end of your talk, but perhaps you'd want to elaborate and whether you have speak more about your preferred option.
Yes, I think the Kubernetes platform is favoring, in my opinion, CRDs, especially when we see that there's the project named Gateway API, which is the evolution of the Ingress API, and we see in that project that all of the input is about CRD. So, in my opinion, CRD here would be the option to get input with the required details for the Ingress controller.
Excellent. Thanks for elaborating. All right. So another question from the chat. What are some of the advantages or disadvantages of using Ingress objects instead of custom CRDs tailored to HAProxy?
Okay, I think the question is more about using annotations, because we use Ingress objects. Anyway, we need to use Ingress objects to be able to provide rules to traffic. But I suppose maybe here we mean using annotations, and one advantage of annotation is their simplicity. So it's quite simple. It's just a key and a value. But that's it. I mean, whenever you want to go in more details, and whenever you want to configure more complex behavior, then, in my opinion, custom resources is the best option here. Would be the best option.
All right, another audience question. When is HAProxy a preferable choice as a Kubernetes Ingress proxy compared to other options out there, such as Envoy, Metal, etc.?
I think that there are two main advantages for HAProxy. So the first would be performance. We have done benchmarks and we have published them on GitHub. So there is a public repository in GitHub where we can reproduce how we benchmark different Ingress controllers, and you can see HAProxy performing very well. So HAProxy is proven to be performant for many years now, and that would be one reason to use HAProxy. Another reason, in my opinion, is if you want many detailed metrics about what's happening. Usually HAProxy, so it is in this case an Ingress controller, is one of the first components receiving traffic. So we want to know what's happening at this level, and with HAProxy we can have many detailed metrics that, in my opinion, are not available with other or not at the same level of details with other Ingress controllers. So that would be a second reason to use HAProxy.
Yeah, but I'm glad you brought up the GitHub for the benchmarks. If anyone is interested in checking that out, it's HAProxy tech/Ingress controller benchmarks. And as Moemen said, you can actually, it's a whole guide to benchmarking the 5 most popular Ingress controllers with out-of-the-box configurations. And we give you all the, the tools are all available there to reproduce those benchmarks. So I think that's been valuable for a lot of folks when evaluating their options when it comes to Ingress controller performance. All right, great. So I guess, Moemen, are there any closing thoughts that you have? Is there anything else that you wanted to talk about that maybe you left out of your talk, or anything else you'd like to leave the audience with?
I would be interested to get traffic from the audience and the community in general to continue with custom resources for the HAProxy Ingress controller. So I would be interested to get feedback about what behavior we would like to implement in a specific custom resource. So this way we can elaborate them with the need of the community, and we can have something useful for everyone. So we are available in Slack, of course, in the community Slack, and also in our GitHub repository. Users can create issues to ask for specific custom resources, and we can discuss that.
Yep, and that's a great reminder to anyone tuning in. If you haven't already, you can go ahead and join the HAProxy community Slack. And as Moemen mentioned, where Moemen and many other folks involved in the community and contributing are there to help answer any questions and engage generally about any topics related to HAProxy. So Moemen, thank you so much for joining us, for your awesome presentation, and for joining us for the live Q&A here as well. Really appreciate it, and hope you do enjoy the rest of the conference.
Thanks. Bye-bye.